guys. All right, so we started this section on Thursday, back before the coronavirus kicked us out of school, and we are going to finish it now. So remember, we were doing section 8.4. We started talking about polynomials. We're going to do a little bit of a review from what we talked about on Thursday, so if you missed Thursday, here you go. What I need you to do is actually take notes. So you already started this section. Don't worry about the review part, but when we get to the new stuff, please write stuff down just like you would if we were actually in class. All right, so let's get started. So we were talking about polynomials, whatever those are, and the big three words that we talked about were term, coefficient, and polynomial, that big word again. So remember, a term, well, that can just be a single number, so like 7, or it could just be a variable like x, or it could be a whole bunch of numbers and variables all multiplied together. The key thing is they need to be multiplied together. So for example, we've got two polynomials here, and I see that we have a term right here because that's just a variable. I see that we have a term right here because that's just a number. But this is actually a term too, because this is really 7 times x times x times x times x times x. And since it's all multiplied together, it's all one term. So we have one term, 2 terms, 3 terms. Same thing here. We got a bunch of terms. So this is all one term because this is all multiplied together. This is all one term, 7a. This is all one term, and 10 is its own term. So this one has 4 terms in it. Okay, so that's terms. We talked about what coefficients are as well. So a coefficient is just, if you've got a term, it's whatever the number is in front of that term. So your number, that's your constant. That's always going to be in front of the variables. Otherwise, it's wrong. It's just weird. So like on this term here, the coefficient is 26. On this term here, the coefficient is, you guessed it, 91. On this term, I don't see a number in front of it. So what number is really there? It's a 1. You know that. And then this one is a little bit weird. You might accidentally say 5, but what do you think this coefficient really is? Yeah, it's -5 because of that minus sign. And then this one, even though we don't see a variable here, this 10 still counts as a coefficient for that last term. So coefficient is the number out front. All right, that's what our coefficient is. And then polynomial, well, that's just all the things that we've been seeing so far. So if you take a bunch of terms and you add them together or you subtract them from each other, now you've got a polynomial. So this is a polynomial because we have term plus term plus term. This is a polynomial. Okay, it's just the big thing that you're seeing there. The whole thing is a polynomial. All right, so the other thing that we talked about is you can have special polynomials based on how many terms they have. So if you have a polynomial with just one term, that's going to be a monomial. If you have a polynomial with 2 terms, that's going to be a binomial. And if you have a polynomial with 3 terms, that's a trinomial. Okay, we're used to that. Mono, bi, and tri. You know those prefixes already. Okay, that's the end of our review. This is new stuff now, so please, please, please add this to your 8.4 notes while we're going through it. So the big thing that we want to talk about first is the degree of a polynomial. So the degree is whatever the highest exponent is in your polynomial. So pause the video here, write it down, and unpause when you're done writing. All right, so let's look at this example here. So we need to find the degree of each of these polynomials. Remember, it's whatever the highest exponent is. So if I look at this polynomial right here, it's going to be one of the exponents, and I see a 4, I see a 2, I see a 1, and I see no exponent. So the highest exponent is 4, which means the degree is 4. All right, looking at this next one, I don't see an exponent in either spot, but it's definitely going to be like whatever is on the x here, because it's always going to need to be on the x. So what number could I put on this x where it doesn't change it? It's still just x. Well, this is really x to the power of 1. So that means that the degree of this polynomial is 1. All right, for this one, I'm looking not at the coefficients, not at the 8, not at the -9, but at the exponents. And the highest exponent I see is 5. So that's my degree here. And then on number 4, right, so I don't even see a variable at all. So I don't want to know what exponent is on the 8. I want to know what exponent is on the variable. So if I did put an x there, how can I make it so that x turns out to be invisible? Well, I need it to just turn into a times 1. Okay, so if I put a 0 here, then that's going to make that x disappear, because then I get really 8 times 1, which is just 8. So if you have just a plain old number, your degree is 0. Okay, so So we talked about how you can have a binomial, a monomial, a trinomial, that's how many terms you have. Well, it turns out that you can also give polynomials names based on what the degree is. So there's 4 special words that we have. They're constant, linear, quadratic, and cubic. And this tells you what the degree is. So if you have a polynomial with a degree of 3, that's a cubic. Well, why would it make sense that cubic has a degree of 3? Take a second and try to think. Well, a cube has 3 dimensions, right? And so that's why we call a polynomial with a degree of 3 a cubic. So a quadratic, remember that's like a quadrilateral. Well, how many dimensions does a square have? Well, 2. So a quadratic is a polynomial with a degree of 2. Linear, well, you see the pattern. That's going to be a polynomial with a degree of 1. And a constant, like the number 8, is a polynomial with a degree of 0. So go ahead, pause here, write these down. Okay, so let's do example 3. So we just need to say what each polynomial is based on its degree. So we could talk about how many terms we have here, right? This one has 1 term, 2 terms, so that's a binomial, but that's not, we don't care about that right now. We want to look at what the degree is. So on this one, I see that the highest exponent is a 2. So what was our word for 2? Oh, a polynomial with, oh, it's a quadratic. Okay, so this one is a quadratic. This one, I don't see an exponent, so I'm looking at this one. What exponent is really on this x? It's a 1, so that means it's a linear polynomial. This one, I don't even see a variable, so that means there must be one of those x's with a 0 on it. So this is a constant. If it's just a number, it's a constant. And then last one, I see that my biggest exponent is a 3, so this one is a cubic. Okay, again, we don't care how many terms there are. Yes, this is a monomial. Yes, this is a binomial. That's not what they asked us. Okay, 2 other new things, and then that's it. So we have something called standard form, and we have something called a leading coefficient. Go ahead and write these guys down. All right, so standard form, we need to rewrite the terms in order from greatest degree to least degree, so highest exponent to lowest exponent. And then the leading coefficient is going to be whichever coefficient is on the first term, but it has to be in standard form first. So let's take a look at this example. It says rewrite this polynomial, there should be an L there, ooh, not a period, in standard form. So this is not in standard form because if I look at the exponents, they do not go in order from biggest to smallest. It goes 4, 6, 2, 3, 1, 0. That's not what we want. So I'm going to find the one with the biggest exponent first, which is this one right here. And I'm going to write that one first. And then I would cross it out. But I don't think I can do that right now. All right, so now I'm going to go ahead and find my next biggest exponent. Well, I have a 4 here. So my next term is going to be 9x to the power 4. Now, do you think I'm going to put plus here or minus here? Well, since this term is positive, it's going to be a plus because I need to add that 9x to the power 4. So it's going to be plus 9x to the power 4. All right, my next biggest exponent is this 3 here. So I'm going to make this term come next. Do you think it's going to be a plus or a minus? That's right. It's going to be a minus because this term is negative. Okay, next term, oh, I see I have a little 2 here, so it's going to be plus 10x squared. Okay, my next term, which one do you think is going to come first, the x or the 15? Well, which one has a higher exponent on it? This one, because this one has a degree of 1, this one has a degree of 0. So we're going to do the x next, it's going to be plus x, and then we're going to do the minus 15 last. Okay, last example. It asks you, hey, what is the leading coefficient of this polynomial? Well, this is the one we just did, so it's already in standard form. So you just want to look at where your first term is, here it is, and what's the coefficient on that term? Remember, coefficient is the number, so it's 2. So the leading coefficient is 2. Actually, I lied to you guys. We have one more example. What's the leading coefficient on this polynomial? Well, is this one in standard form? Pause. Is it in standard form? No, because I am not going in order with my exponents here. So I would need to change it to standard form first. Well, we only care about what the first term would be anyway. So if we did change it, the first term would need to be this one because it has the highest exponent. So that means that this coefficient is actually my leading coefficient. So this one has a leading coefficient of -9. All right, that's it for our notes. For your assignment, you're going to have to do these Frere models that you were supposed to do over the weekend anyway, but we're going to add a couple new words because we just learned a couple new words. So check Google Classroom for more details on that. Bye.